I think you guys will.
What?
You guys will get 100. Probably next week. Yeah,
There's
before
like 7
before the break.
lessons.
Yeah, we'll have a. I don't know. I'll figure it out. Not Friday though.
No. There are 7 lessons.
Not Friday. It won't be Friday.
It won't be Monday.
No, but there are 7 lessons.
Are we doing it on Wednesday?
We could do it on Thursday. No, Friday be like a free day.
Well, Thursday or Wednesday. I don't know. I'll ponder about it during the weekend. I'll think about it over the weekend.
Thursday's not Friday.
If I have a good weekend, I'll make it Thursday. If I have a bad weekend, it's Friday. It'll be on
Okay.
Wednesday. Okay. So, you guys can quiet down, please. Thank you. So again, we know what an exponent is. We know my base is the number that is going to be multiplied. So the 2 is my base. And we know my 3 tells us the amount of times I have to multiply 2 by repeatedly. How many times 2 multiplied 2? So in this case, 2 to the power of 3 means I'm just multiplying 2 3 times over. It'd be 2 times 2 times 2. And all of you should know this. What's my answer? 2 to the 3, Matthew? 8. It gives me 8. Okay? Remember, an exponent is just telling you how many times I have to multiply my base by. Okay? So if it's a 3, I multiply it 3 times. If it's 4, I multiply 2 4 times. So if it's 2 to the 4, I multiply 2 by 2 4 times over. 2 times 2 times 2 times 2. And that gives me the answer of 16. So there are different laws that we're going to learn about when it comes to exponents. Each of them are different and will be used when needed to be used. So let's see. Okay. So the first law that we have is called a power of a power. So basically it's an exponent raised to another exponent. So I have my number, which is m. So m is my base, which is raised to a certain exponent and then raised to another exponent. So the rule to this is to raise a power to a power, we need to multiply my exponents. So if I have a base, say, of 3, and I have an exponent on top of it, which is 2, and then I have it to the power of 4, I would have to multiply those exponents together, the 2 and the 4. So what would this simplify into then? 3 to the power of what, Sean? 3 to the power of 8. You multiply these two numbers together. So 2 times 4 gives me 8. And then I may ask you guys to evaluate. And when I ask you to evaluate, what am I asking you to do? Kareem. Yeah, what's my answer? What's 3 to the power of 8? Use your calculator.
3 times 8. 3 times 3, 8 times.
3 times 3 times 3 times 3 times 3 times 3. Do you have it? You're thinking?
They're doing 8 times.
It's 6,561.
Hold on, just type it in. Whoops. I don't even have my. Okay, Bashar, you can say it now.
It's 6,561.
It's not 61.
What?
6,561. Okay, I'm pretty sure that's what you said, Bashar. He just didn't hear you properly.
Oh, okay.
6,561. Okay, so when I ask you to evaluate, I'm asking you to give me the answer.
I did 3 to the power of 8, and it was the same answer, 6,561.
It's good. So now we'll try one more example to see if you guys get this. So let's do 2 to the power of 3 to the power of 3. How would I write that as one power? Matthew.
2 to the power of 9.
Yeah, 2 to the power of 9 And if I ask you to evaluate it, what is 2 to the power of 9? Ethan.
512.
Yep, it would be 512. So again, whenever we see something with a base, like I said, 4 to a power, let's say 3, and to the power of 4, all you're going to do is you're going to multiply the exponents.
So it's like this, whenever you see something like C2 to the power of 3, but then you see a power outside, you
Yep,
multiply it,
Exactly.
then you evaluate it, and then you get the answer.
Mm-hmm. Exactly.
Now I understand.
Cool. So everyone's good with this one? Power to a power?
Yes.
We're good?
Yeah, we understand.
All right. The next exponent law we have is called a power of a product. So when we don't have an exponent on top of my variable or number, what is that exponent assumed to be? So if there's no exponent on top of the 2, the m, or the n, what can we assume its exponent is? Gian. 1. They all have a 1 as their exponent when they have nothing written on it. Okay? Yep. Whenever you have, say, just x by itself, technically it's x to the power of 1. Mhm. So the power of a product tells us that we need to apply the exponent on the outside of the bracket to every single number or variable inside of the bracket. Okay? So we have this a. I need to distribute it to my 2, to my m, and to my n. So in this case, because it's basically another power to a power, I have to multiply my exponents. A times 1 just gives me a times 1 gives me a, and n times a gives me a as well. So I'm going to give you guys an example. Let's do the same thing. We'll do 2 to the power of 2 times n to the power of 3 times n to the power of 2, all to the power of 2. So who can tell me what my first term is going to be, or my first bracket? Gian? Yep, 2 to the 4. Again, we have a power to a power, so I multiply. So it's going to be 2 to the power of 2 times 2. I'll do it the long way. What's my next one going to be? Matthew?
M to the power of 6.
Yep. So we're going to do m to the power of 3 times 2. And what's my last one going to be? Yazin?
I might be wrong, but is it n to the power of 4?
It's n to the 4. So 2 times 2. So like Gian said, it gives me 2 to the power of 4 times n to the power of 6 times n to the power of 4. Yes, Kareem?
So you multiply the the outside exponent with the ones that inside.
Mm-hmm. Because it's technically still a power to a power. So for this one, I'm going to say we use the power to a power rule. Yep.
Why is n times
3 times 2, because my exponent here is 3, and I have a power on the outside, which is 2. So it's technically a power to a power, so we have to multiply those numbers together. So I'll do another one.
Oh, you just gave n.
I just gave m an exponent 3.
Oh, okay,
Yeah.
okay.
So who can tell me what this one's going to be? I have 3a squared b4 to all to the power of 2. Kareem,
So for the 3a, 2 times 2, right?
you're forgetting about the 3.
Sorry.
You're forgetting about the 3.
Oh, are they both? They both have like exponent 20.
Nope. Whenever you don't have an exponent, it's a 1.
Okay, so 1 times 2.
Mhm.
Is 2.
Okay, what's the other one? The next one? Austin?
Would it be
Yep. And someone with the last one, Kareem.
B is the power of 4 times 2.
Mhm. So 1 times 2 is 2, so I get 3 to the power of 2. 2 times 2 is 4, so I get a to the 4. 4 times 2 is 8, so I get b to the power of 8. Now, what I forgot to do with this one here is whenever I have 2 to the power of 4, like this, I can obviously simplify it. What's 2 to the power of 4? Adam. Yeah, so this becomes 16 m6 n 4. So what would my final answer for my black question be? The one in black pen. Gian? Mm-hmm. So are we good? Easy to understand?
So, sorry, are you really, like, powered, dual solving for,
The number, because that's the only one I can solve for. Because A and B can be any number I want to be.
so if A and B were actually a number, would you also solve for them?
And then we have 2 more rules. So I'm going to let you guys finish copying this down before I move on. So a power to a power, we learned that we have to multiply the exponents. We have something called a product rule and a quotient rule. So when I have exponents with the same base, what do you guys think I'm going to do with my exponents? Laura? We're going to add them.
Yep. Add the exponents.
So the product rule is when multiplying powers with the same base, we're going to add the exponents together. So I'm going to have 2 numbers. M has to be the same, and my exponents can be different. So for example, if I have 2 to the power of 2 times 2 to the power of 3, that would give me 2 to the power of 5. And the reason being is because I write 2 to the power of 2 as 2 times 2. I write 2 to the power of 3 as 2 times 2 times 2. And as you can see, we have 5 2's, so which means my exponent is going to be 2 to the 5, which is why we add the exponents together. Now let's see if someone can give me this one. Let's try 9 to the power of 4 times 9 to the power of 3. What would that give me as a single power? Maya. 9 to the 7. Okay. However, what if I have this guy over here? An example like this. What can that simplify into? Or can it be simplified?
9R7?
No.
No, 3 times.
Look at the definition. What's in caps?
So,
Do they have the same base? No.
no.
So when they don't have the same base, you would have to evaluate each exponent individually. So you would have to do 6 to the power of 4 first, see what that gets you. Do 3 to the power of 2 and see what that gets you, and then multiply those together. So can someone tell me what 6 to the power of 4 gives me? 6 to the 4. My,
1,296.
okay. And what's 3 to the power of 2? Alice? 9. And now we just multiply those two numbers together, and that should give me 11,664. Okay, so again, when we don't have exponents with the same base, you have to evaluate each exponent individually and then multiply the two numbers together. Okay, and then the next rule is the quotient rule. So obviously, if we add when we multiply, what are we going to do when we divide exponents with the same base? Yeah, we're going to subtract. So when we have exponents with the same base, we are going to subtract my powers, okay, my exponents. So instead of using the division sign, what are we using instead? The fraction sign. So for example, I have 3 over 8 over 3 over 5. What would that give me as 1 power? Simplify that to 1 power. Gian? 3 to the 3. So for those of you who are asking why, so 3 to the power of 8 is written as 3 times 3, 8 times. I hope that's 1, 2, 3, 4, 5. Good. And 3 to the power of 5 is written 5 times. 3 times 3 times 3 times 3 times 3. Now, what you're going to notice here, the reason why it's 3 is because when we have numbers like 3 and 3 dividing by each other, what would it always give us? 1. So basically, I don't need these 3's because they're all going to give me 1. So how many 3's are left over? 3, which is why we get 3 to the power of 3. Okay. Now, let's see if I give you guys this example. 2 to the power of 5 divided by 2 to the power of negative 2. Again, use the same thing. We're going to subtract the exponents. Gian, what would it be? 2 to the 7. Because we got 2 to the power of 5 minus negative 7, or minus negative 2, sorry. And when we have two negatives separated by a bracket, what do they become? Laura? Positive. So it's basically the same thing as saying 5 plus 2. And like Gian said, it's 2 to the power of 7. And yes, there are negative exponents that exist. And I'll show you as to why when we get to the 0 exponent. What's an exponent that's 0? Oh. How? I'll show you how.
Yeah, it's the number of multipliers of 0 times.
Mhm.
0?
No,
Explain.
I will. You have to get to two more rules. Okay, so the second last rule we're going to talk about is the power of a quotient. So here we have two different bases, or two exponents with two different bases. So let's say we have 2 to the power of 3 divided by 4 to the power of 2, all to the power of 2. So what do you guys notice right away with this? 2 to the power of 3 to the power of 2. What law is that?
I got lost cobwebs, how do they multiply?
Yeah, it's called the power to a power. Okay?
Six
So we have 2 to the power of 3 to the power of 2. And in my denominator, I have 4 to the power of 2 to the power of 2 as well. So this c, because it's a power to a power, we have to multiply it by the exponent on the numerator and also multiply in the exponent in my denominator. So Matthew, what would my answer be?
2 to the power of 6 and 4 to the power of
Yep. 4 to the power of 4. Now, I can simplify this even further. Okay? Let's look at this 4. Can I write 4 with a base of 2? Can I write 4 as an exponent with a base 2?
Okay, yeah.
Yasin, what is it?
It's gonna be a 2 to the power of 2.
So I have 2 to the power of 6 on top. And then I have 4, which is written as 2 to the power of 2. And that would be all to the power of 4.
Yeah.
So then how would I simplify this guy then? Multiply. So what would my bottom number be?
8.
And because I'm dividing fractions, what would my final answer be?
This is a fraction.
So because I'm dividing exponents with the same base now, what would it be? Laura?
2 to the power of negative 2.
Okay, how else can you write that? Let's see, take a guess. We never want a negative exponent on the top.
Negative 2 to the power.
Oh, no. Gian probably knows.
1 over 2 to the power of 2 is 4.
Can you explain?
Um,
Do you know how to explain it?
the negative.
Let's not talk about reciprocals. Let's talk about patterns. No? Okay, that's fine. I'll explain the negative exponent after. So this is what you call a negative exponent. We never want them on top.
Why?
Because you can always write it in terms of a fraction, and I can show you why once I explain the power of 0. So now let's take one more example, one that doesn't involve this. So this is the easier example. So this is easy right here. So I have 2 to the 3 over 5 to the 2, all to the power of 3. Who can tell me what that one becomes? Matthew.
2 to the power of 9 and
Mhm.
2 to the power of 6. 5.
Mm-hmm.
5.
Perfect. Good job, Matthew. So 2 to the power of 3 divided by 5 to the power of 2 becomes 2 to the power of 9 divided by 5 to the power of 6. Again, we're using our power to a power rule. So 3 times 3 gives me 9. We get the 9 from doing 3 times 3. And we get our 6 from doing 2 times 3. Everyone's following so far? All good? Kinda-ish? I'll show you after. And the last one, so I'm going to let you guys copy. I'm just going to introduce it. The last one we have is called a 0 exponent. So I think you've seen it. I think you may have seen it once already on the quiz. What is anything to the power of 0? Sean, why? It's not, huh?
There's no reason.
There's a reason. Laura?
Because it's like you're dividing the number by itself.
Yeah. And that's when we get to negative exponents. So if you continue the pattern, Laura, think why negative exponents exist.
When anything is the exponent of 0, that's when it equals 1.
It equals 1 because you're dividing the number by itself.
Yep.
So the 0 exponent helps us explain negative exponents. Okay, so we'll worry about this guy after, whatever. So the 0 exponent states that anything to the power of 0 is going to be 1. So we'll do this one first and then I'll explain the reasoning. So my base is 2 over 3. So this is the same base and this is the same base. So what are we going to do with my exponent 4 and 3?
Multiply?
Nope, it's not power to a power. Add.
What?
A power to a power, Matthew, is when you have 2 to the power of 2 and then there's an exponent outside of the bracket.
Divide.
No, when you multiply exponents with the same base, you add. Okay, this one you're going to add. So you're going to do 4 plus 3.
7.
Yeah.
And if we get 8 over
Wait,
3.
sure, 4.
Yep, 4 plus 3. So now my bases are still 2 over 3, but now I'm dividing my exponents. What am I going to do with my 7 and my 7? Gian. I would subtract. So my final answer would be 2 over 3 to the power of 7 minus 7, which gives me 2 over 3 to the power of 0. And we know that that answer is always going to be 1. Now, let me show you why. So let's start with 2 to the power of 5, and then 2 to the power of 4, and keep going in descending order. Do I have enough room? You gotta have enough room. Okay, I'll let you guys copy this. I'm just gonna scroll back up. Okay. What is 2 to the power of 5? Laura?
Wait, oh yeah.
You got it.
32.
32. 2 to the power of 4? 16. 8. 4. Almost did not know the answer. 2 to 2. 2, and then ultimately we will have what is going to be 1. So let's go in descending order. 32, 16. What's the difference? What do I divide by? Adam? 2. 16 divided by 8 gives me 2. 8 divided by 4 gives me 2. 4 divided by 2 gives me 2, which means 2 divided by 2 would give me what? 1.
1.
Which is why 2 to the 0 will be 1. 3 to the power of 0 is 1. 5,000 to the power of 0 is 1. Anything to the power of 0 is 1.
But decimal.
That's where we get into negative exponents.
Yep.
So 2 to the negative 1 equals what? So if we continue that pattern, 1 divided by 2, what does that give me as a fraction? Matthew.
Oh, fraction, I don't know.
Well, division is the same thing as fraction. 1 over 2. Okay, and if you go on your calculators and you type in 2 to the power of negative 1, what value is it going to give you?
It's half, 0.5.
So when you type in 2 to the power of 1 in your calculator, what value does it give you? Everyone got 0.5? Okay. And we can keep continuing this pattern with negative things, with negative exponents. So what would 2 to the power of negative 2 give me? Nope. Laura? A quarter.
Yep,
1 over 4.
0.15.
Okay. What would 2 to the power of negative 3 be? Matthew?
Maybe 1/8.
1/8. Okay. So as you can see here, my negative exponents, it's a word that starts with an R, and you've seen it on your tests. My negative exponents are what of my positive exponents? Starts with an R. You guys asked me like this question when you were doing the review. Adam. Reciprocals. So the negative exponent is just the reciprocal of your positive exponent. Reciprocal is just another way of saying you flip your fraction over.
Positive.
So we know that 2 to the power of 5 gives me 32. Okay. So if we have 2 to the power of negative 5, okay, this is all over 1. Remember, I have a denominator of 1. 2 to the power of 5 already has a positive exponent. Great. I don't have to do anything to it. However, 2 to the negative 5 has a negative exponent. I don't want negative exponents to be in my numerator. So when I talk about the reciprocal, what did I say you do to the fraction in a reciprocal? Adam, you flip it. So your 2 to the negative 5 comes to the bottom, which makes it positive, and your 1 comes on top. So you get 1 over 2 to the 5, and that gives me 1 over 32. And if we continue this pattern with 2 to the negative 4, it's going to give me 1 over 16, and 2 to the negative 5 will give me 1 over 32. So whenever you see a negative exponent, I want you guys to always try your best to change it into the reciprocal, which is this guy over here. I'm going to outline it in red. Okay, it'll come with practice, okay? That's fine. But it's better to learn it now than to have to learn it new in grade 10. So let me just draw this with a, okay. So you see how 2 over 2 to the 2 is positive 4, right? What's 2 to the power of negative 2? Says right there, 1 over 4, right? So let's say I take the number 4, and we know it has imaginary 1 as its denominator. Claire, if I ask you to tell me what the reciprocal of that is, what would it be? Right? So 4 and 1 over 4 are reciprocals, which means 2 to the power of 2 is which means 2 to the power of negative 2 is just the reciprocal of 2 to the 2. Okay? So for example, if I ever ask you what like 3 to the power of negative 2 would be, what would you say it is? Yeah. Use that same idea. Figure out what 3 to the power of positive 2 is, and then take the reciprocal, and you'll find 3 to the negative 2. Yep. So 3 to the 2 is equal to 9, which means that 3 to the negative 2 is equal to 1 over 9. So you guys can watch this again at home and hear my awesome voice saying this over and over again.
What's the YouTube channel again?
Oh my gosh, Kareem, you're not.
Come on, you gotta be serious. Come on.
Well.
Come on, it's grades with Garcia.
I'm joking.
Grades with
Okay,
Garcia.
we're gonna do 3 examples. We're gonna do A, C, and E. And then the rest you guys can do after. So can someone tell me what 4 to the power of 3 times 4 to the power of 2 simplifies into? Maya. 4 to the 5. Remember, this is the power of a product. So because we have this, we're going to add my exponents. Okay. Next one. Because x doesn't have an exponent, what do we assume it is? What number? 1. So who can tell me what x to the 5 divided by x to the 1 gives me? Sean.
X to the 4.
Yep, x to the 4. So wherever we see division, we're going to subtract. Yep. And then the last one, which is 3 to the power of 4 to the power of 6, what rule are we going to use? Maya?
You're gonna multiply 4 by 6.
Yep. When you see a power to a power, you are going to multiply the exponents. So what would my answer be? Someone? Alice? Yep. So you go 3 to the power of 24. The question asked me to write it as a single power. This would be your answer. I'm not asking you to evaluate. Okay? This would be your answer. Just 3 to the 24, x to the 4, and 4 to the power of 5.
If it's a variable, when we like rewrite it in like the only one exponent,
You can,
we use variable and not
Exponent.
Like one.
you would just use the variable and then the exponent it has. So like for example, the answer for C is just a variable and an exponent. You would just leave it at x to the 4.
If we wrote it as 1, and if we wrote it as 1 to the 4, wouldn't be wrong.
Yeah, because I never said x was 1. So if you like want to remind yourself on like a quiz or test, you can always put the exponent 1 on top of the ones that have exponents missing. That way it'll help you figure it out easier. Okay. And last but not least, we have, I think we're going to do 2 more. Let me scroll down here.
G, H, I, J.
Oh, we're not doing those. So what we're going to do here is we're going to simplify. So put it into 1 power and then evaluate, which means give me my answer. So let's start with the first one. How can I write negative 6 to the 6 divided by negative 6 to the power of 2 as one singular power? What would it be? Gian.
Wait, hold on, can I see it? That's the negative. That would be negative 6 to the 4.
Yep. Negative 6 to a 4. And when I ask you guys to evaluate, what is negative 6 to the power of 4? Maya?
1,296.
Yep. 1,296. Perfect. And then we'll do D at the end. So for D, I have negative 4 to the power of 3 to the power of 2. So how am I going to write this as a singular power? Pardon?
Is it negative 4 to the power of 5?
Oh, power to a power. What do we do? Maya?
Negative 4 to the power of 6.
Yep. Negative 4 to the power of 6. So now to evaluate, we're going to use BEDMAS. So start with the exponent in the bracket first, and then multiply it by your negative 1. So what's 4 to the power of 6? Right?
4,096.
And because I have that negative on the outside, what's technically the correct answer? What should be the correct answer?
Negative.
Yep.
4,000.
Mm-hmm. Okay. I think that's enough math for today.